PV diagram is simply a graph between pressure on the y-axis and volume on the x-axis. For irreversible processes, the PV diagram is a dotted line, since the intermediate states are disconnected and cannot be reached again without external work. Contrastingly, for reversible processes, the PV diagram is a continuous line, since all the intermediate states can be reached again easily. The work done in processes can be calculated by finding out the area under the PV diagram or PV curve, since work done is equal to integral of P dV. For an isochoric process, the PV diagram is a vertical line. The volume remains constant, but temperature or pressure changes. Since by Gay-Lussac's law, P is proportional to T. A change in temperature and pressure at constant volume is plotted as a vertical straight line. For an isobaric process, the PV diagram is a horizontal line. The pressure remains constant, but temperature and volume changes. Since by Charles' law, V is proportional to T. A change in temperature and pressure at constant pressure is plotted as a horizontal straight line. For an isothermal process, the PV diagram is a parabolic curve. The ideal gas law states that PV is equal to nRT. For a given system of gas, the number of moles, N, is constant, and so is the ideal gas constant, R. When the process is isothermal, all three terms in the RHS are constant, so PV equals constant for an isothermal process. When PV is equal to constant, P is equal to constant by V. So, P is inversely proportional to V. The graph for such a relationship between P and V is a parabolic curve. This is also known as Boyle's law. For an adiabatic process, the PV diagram is again a parabolic curve. The equation for an adiabatic process is PV raised to gamma is equal to constant. So, P is equal to constant by V raised to gamma. Or in other words, P is inversely proportional to V raised to gamma. The graph for such a relationship is a parabolic curve. Note that this graph is steeper than the isothermal graph. This is because gamma is greater than 1, and so V raised to gamma is greater than V. Then, since P is inversely proportional to V in both isothermal and adiabatic processes, for any given change in volume, the change in pressure is always greater in an adiabatic process compared to an isothermal process. And so, the graph of adiabatic processes is steeper than that of isothermal ones.